Inside a hangar at Hill Air Force Base in August 2025, an F-35A sits under fluorescent lights with its belly split open, bay doors yawning like a vault. A small team in gloves and headsets rolls a long gray cylinder toward the jet on a low cart. Cameras are rarely allowed this close to nuclear operations. The object is the same shape, same weight, same interface as America's primary nuclear gravity bomb, the B-6112, and they're sliding it into the internal weapon bay of the world's most advanced stealth fighter as casually as loading for a routine sortie. The F-35 is being prepared for a nuclear mission that everyone hopes it will never fly. For decades, NATO's air-based nuclear role used older fighter jets such as the F-16 and the Panavia Tornado. Instead of internal bays, these planes mounted B-61 freefall bombs on outer racks, relying largely on rapid movement and specific altitudes to hit target zones. That approach is much harder to sustain nowadays. Modern air defenses are not single radars protecting a target area. There are now integrated networks of sensors and interception systems that share tracking data and engage aircraft at long range. The earlier an aircraft is detected, the more time those networks have to coordinate a shot. If a nuclear delivery aircraft is easy to track, the chance of reaching the target drops sharply. And if the delivery platform cannot credibly penetrate defended airspace, the mission's deterrent value weakens. That was the problem the Pentagon was trying to solve when it committed to a new dual-capable aircraft. The Air Force needed a nuclear strike platform that could remain viable against evolving defenses into the 2030s and 40s. The answer was to give the F-35A a specific job. It would become the first fifth-generation fighter certified to carry the new B-61 variant, the life-extended, precision-guided member of the B-61 family intended to replace older Cold War models. Survivability drove how that weapon would be carried. Instead of hanging it on external racks, Jet holds it inside its weapons bay. Keeping the payload internal preserves the aircraft's low observable profile all the way to the release point. The airframe also brings a different level of awareness to the mission. Its onboard systems fuse radar returns, electronic warning data, infrared tracks, and off-board inputs into a single picture for the pilot, reducing uncertainty about where threats are and helping the aircraft navigate defended airspace with more information and fewer guesses. Now that the system is operational, NATO allies preparing for the same mission are moving to adopt it as well. Inside the alliance, though, the nuclear role is not shared evenly. The United States owns the B-61 bombs. They remain under U.S. control, even when stored at bases in Europe. A small group of partners, however, supplies the aircraft and crews that would deliver them in wartime. These are called dual-capable aircraft, or DCAs. They keep the nuclear deterrent in the air and form its most visible element. Submarines are hidden. Land-based missiles sit in fixed sites. Aircraft can deploy forward, shift between bases, and fly in exercises, giving NATO a practical way to show it's ready. Once the F-35A entered the DCA mission, it became the platform nuclear-sharing states were expected to move toward. That shift is already in motion. The Netherlands was the first to transfer its nuclear tasking from F-16s to F-35As. Italy is following, as its Tornado IDS fleet retires. The United Kingdom has announced plans to purchase F-35As to rejoin the airborne nuclear mission, and Germany has chosen the same aircraft as its future DCA platform. Belgium is phasing out its F-16s by introducing F-35As. Given its role in NATO's nuclear sharing, it's likely these jets will take over the deterrence task after infrastructure updates are complete, although officials tend to speak of this shift with restraint. Timelines differ, but the vector is the same. The F-35A is becoming NATO's next dual-capable aircraft. Legacy jets assigned to the role are nearing the end of their service lives. Russia's posture has brought nuclear signaling back into everyday planning. And for the first time, several Allied air forces will share a common fifth-generation platform for this mission, allowing tighter alignment in training, basing, and tactics. This would turn separate national squadrons into a more integrated deterrent system. Once the aircraft is standardized, the next step is to show that the combined system stays reliable. In the early hours of August 19, 2025, a quiet corner of Hill Air Force Base came to life. Under portable lights on the flight line, Air Force crews and Sandia National Laboratories technicians rolled B-6112 shapes across the tarmac as part of a 3-asset test set. They were joint test assemblies featuring the full weight and full geometry replicas of America's newest nuclear gravity bomb, identical to wartime versions, except for the missing nuclear package. By sunrise, the inert rounds were loaded into the twin internal bays of an F-35A. Technicians moved through the checklist, confirming mounts, connections, and systems, before the jet took on its first B-6112 stockpile surveillance drops. From August 19th to 21st, Sandia and the National Nuclear Security Administration flew multiple sorties from Hill to the Tonopah test range in Nevada. The F-35s ran captive carry profiles with the bombs on board and released them for live drops. Sandia said these were the only B-6112 F-35 events in the 2025 campaign and labeled them a milestone in validating aircraft, weapons, and crew performance as a single system. Before at least one release, testers also conducted the first thermal preconditioning of the B-6112 assembly inside the F-35, heating the bomb to simulate real-world temperature stress, and then confirming that its electronics, guidance kit, and mechanical tolerances remained within limits. Sandia surveillance lead Jeffrey Boyd called the effort the capstone of years of planning and the largest B-6112 flight surveillance push, expected for the near future, important now that the weapon is fully fielded. The tests fit into a broader modernization arc. The B-61 family has been in U.S. and Allied service for more than 50 years, and in December 2024, the NNSA completed the B-6112 Life Extension Program, adding at least 2 decades of service and replacing older B-61 3, 4, and 7 variants. Integration work and a guided tail kit keep the bomb viable on platforms including the B-2, F-15E, F-16, and now the F-35A. These events took place before President Trump's late October call for renewed nuclear weapons testing, and they did not involve nuclear detonations. Energy Secretary Chris Wright later confirmed that current work is limited to subsystem and reliability testing. To understand the significance, it's important to look at the actions. America's main competitors are taking on the other side of the board. They're doing 2 things at once: modernizing their own airborne nuclear forces and building air defenses designed to make a stealth strike like this harder to execute. Starting with Russia, Moscow continues to see long-range bombers as a clear sign of strength in its nuclear strategy. Yet efforts focus on sustaining this capability through upgrades to aircraft such as the Tu-160M or modified versions of the Tu-95. Despite damage from Ukrainian drones in mid-2025, experts say Moscow still uses these aircraft for long-range flights and political messages, though missiles remain central to its nuclear threat. China is advancing similarly, yet at a quicker pace. By 2025, Beijing had publicly displayed all components of its nuclear triad during a single parade. This included a newly revealed air-launched nuclear weapon linked to the H-6N bomber. As such, the airborne capability became an openly emphasized part of China's deterrent strategy, instead of remaining understated or secondary. Open-source images, along with military assessments, reveal the H-6N equipped with a sizable ballistic missile designed for nuclear use, providing China with an aerial standoff capability. This development adds complexity to U.S. and partner defense strategies. At the same time, each nation is developing defenses aimed at countering missions like those carried out by the F-35A. Russia responds with a layered air defense network that includes interlocking radar systems and extended-range surface-to-air missiles, alongside electronic warfare tools meant to spot threats sooner and strike from afar. Systems such as the S-400 serve a central role. Meanwhile, updated models, including the S-500, are promoted to counter-stealth aircraft, yet independent experts question whether these capabilities perform effectively in actual battlefield scenarios. Furthermore, China is fielding its own layered network, investing heavily in radar coverage and long-range SAM families such as HQ-9 variants, and promoting anti-stealth sensor development as a strategic priority. To keep up, the next phase for the F-35A is operationalizing what Tonopah proved by turning a tested capability into routine. That translates to regular surveillance flights and checks to keep the system within spec as it ages and evolves. Nuclear missions are maintained much as the aircraft themselves are. Performance is re-verified as software changes, airframes accumulate hours, support equipment is updated, and the stockpile moves deeper into its service life. As more F-35A squadrons reach full dual-capable readiness, the nuclear mission in the air starts to look less like a specialty task for a few units and more like a normal part of fifth-generation operations. The practical result is flexibility at scale. Squadrons can move between bases, draw on a larger pool of trained pilots and maintainers, and participate in exercises as a coordinated multinational package rather than as separate national units. The mission becomes easier to repeat and to plug into broader plans, and harder to single out or pressure. This shift will reshape how the Alliance trains. Exercises that once centered on older aircraft will increasingly be built around fifth-generation strike packages, all operating under the tighter command, security, and handling rules that come with nuclear work. On the surface, that looks like more realistic rehearsals, with the jets now tied to the mission. Beneath the surface, it builds confidence that procedures, crews, and weapons can operate together without major gaps. For the Alliance, the main advantage is speed through standardization, and several air forces use the same aircraft for the same role. Changes in tactics and training can spread across the group, rather than staying within one country's playbook. For the United States, the advantage lies in control of the support system behind the scenes. The laboratories, certification criteria, surveillance schedule, and stockpile management that define what ready means, and keep the weapon and its interfaces within that standard. Rival states will continue to develop stronger air defenses, electronic warfare capabilities, and sensors to detect or disrupt stealth aircraft. But the direction of travel still works against them. A deterrent built on a stealthy common platform that's regularly tested and verified is harder to dismiss and harder to defeat.